Hello everyone, I myself Sri Shuchintakindi will be explaining you some concepts about ALU, that is the Arithmetic-Logic Unit. Now this is the catalog or the content that we'll be going through today. We'll be learning about what is ALU. We'll be looking at the building of 1-bit ALU, looking at the code of implementation of ALU, and we'll be also learning some advantages and disadvantages of ALU. Now let's first of all go through to the machine cycle. Like where does this ALU come? In the CPU, we have three main components, that is the main memory, the control unit, and the ALU. So now the control unit fetches the data or the instructions from the main memory, decodes it into some commands, and passes it to the ALU. Now what are these commands? These commands are the operations that are supposed to be done on the operands. So this ALU executes those commands and stores the result back into the memory. So we can say that the CPU of a computer is comprised with digital circuits called Arithmetic-Logic Units, that is the ALU, which are capable of performing billions of arithmetic and logical operations every second. Now coming to the main question, what is ALU? ALU is a digital circuit used to perform arithmetic and logic operations. What are these arithmetical and logical operations? Arithmetical operations are like the addition of the operands, subtraction of the operands, etc. Coming to the logical operations is the finding out the and or not operation of the operands. Now, this ALUs represents the fundamental building block of the CPU. Now, in the modern CPUs, we have very powerful and complex ALUs. And in addition to those powerful ALUs, we have the control units. Now, coming to the point, who thought or who proposed the point of or proposed the concept of ALU? He was a mathematician, John Vaughan. He proposed the ALU concept in 1945 in a report on the foundation for a new computer called EDVAC, Electronic Discrete Variable Automatic Computer. Now, looking at the symbol of ALU, we have the first two points, that is A and B, which are the operands of the ALU on which all the operations will be performed. Now, the F indicates OP code, that is the operation code, that is the command. Now, OP code is a sequence of zeros and ones, which tells us which operation is supposed to be done on the operands. R indicates the output. It will give us the output after completing or after executing the commands on the operands. Now, the D indicates output status. In some cases of performing the commands, we need carry in, carry out, etc. type of points, which will be taken help by the D point, that is the output status. Now, coming to the next point, let's build a 1-bit ALU. To start with a 1-bit ALU, we first need to build a 1-bit arithmetic circuit, a 1-bit logic circuit, and join both of them with a mux, and the resultant circuit is known as the ALU. So to start with, we'll be going through the arithmetic functions and logical functions, which will help us in building the arithmetic circuit and logic circuit. Now, arithmetic circuit will be having the points which will be completing the arithmetic functions. Like if I want to add the both operands, the resultant form should be f is equal to a plus b. So in the same way, the arithmetic functions mentioned here are all the functions that are supposed to be done or executed by the arithmetic circuit. So for doing so, we can use a full adder, a parallel adder, which will have a carry in, carry out for some situations. And for others, we can just use the operands and complete the addition, subtraction, decrement, transfer, or anything. Now coming to the logic functions, these are the functions that are normal, that is like or, exclusive or, and complement of A. So we can just directly take these four logic gates, put them together with a mux, and the resultant formed will be the logic circuit. So this is a small example about a 1-bit ALU. So here we can also add the exclusive or and the not, that is the complement gate, which will form the 1-bit logic circuit, and the 1-bit full adder shows us the 1-bit arithmetic circuit. So joining both of them with a mux will give us the resultant as the 1-bit ALU. Let's go through the implementation of ALU by using some coding. Now, an ALU is usually implemented either on standalone integrated circuits such as 74181 or as a part of more complex AIs. So let's go through the code given here, which is simply the code for 8-bit ALU. So here A, B, OP, and Y are the variables we can see right now. So A and B are the operands, A and B. OP indicates the OP code and the Y indicates the resultant. So now here on the second picture, we can see that case OP is. So here we check that if the OP code is the particular sequence of zeros and ones, then the resultant of that particular command should be stored in that Y. So in the first case, we have when 0, 0, 0, when we have a sequence of 3 zeros, then the resultant should have the addition of the operands, and in the same way, we have all other OP codes. Coming to the next point, we'll be going through the advantages and disadvantages of ALU. First of all, let's look at the advantages of ALU. It supports parallel architecture and application with high performance. It has the ability to get the desired output simultaneously and combine integer and floating point variables. It has the capability of performing instructions on a very large set and has a high range of accuracy. Two arithmetic operations in the same code. Like if we want to perform more than one arithmetic operation in one OP code, we can do it. Like in the example given here, we have A plus B into multiplied by C. We can also perform more arithmetic operations in the same code. We can use many operands and many operations in the same particular code. So going towards the next advantages, there are no sensitivity issues and no memory wastage with ALU. They are less expensive and minimize the logic gate requirement because the ALU already has the main logic gates that are required for the logic circuit. They are less expensive and minimize the logic gates requirement because through the whole program, they remain uniform and they are spaced in a way that they cannot interrupt part in between. Now, coming to the disadvantages of ALU, we have 4 advantages of ALU. With the ALU, floating variables have more delay and the designed controller is not easy to understand. The bugs would occur in our result if memory space were definite. If we keep a particular limit for the memory when we are working with the ALU, then we come across many bugs. A proven disadvantage of ALU is that there are irregularities in latencies, and another demerit is rounding off, which impacts the accuracy. It is also difficult to understand the concept of pipelining when we are working with the ALUs. Hope you liked the video.